Okay, so if I don't want to set position. I would just want to read into this. So I'm doing cursor new where I'm starting at 20 in. So this is from Packfile Bytes. Now slicing off doesn't actually, it creates a new one, but the other stuff is still there. Okay, so just starting at 20, probably. Wait, is that correct? 20 has the header. And then I want to get another shoot. If you get stuck with something, people might come join and help. Absolutely, yeah. That's a really good use case for streaming, is like basically learning in public. Learning together. Okay, so I just want to read. Okay, so we're ignoring X bytes. We need to figure out how many we go. So we know that it's we know that we're starting here with 20, so we know it's at least 20. But then we go into read, type, and size, which you go in. Oh, because it's okay. So Scott, hello. How are you doing today? Also, the Discord channels are great. Mine is awesome, and so does Bunnyville. Bunnyville is great. ToggleBit has a really great community, and there's a lot of people in that community. There's way more discussion that happens there than in mine, but we're slowly growing. And so if it's one of those things where we do have, like if somebody posts a question, we usually get to it and are able to answer. And oftentimes when there's a question that happens overnight, somebody else comes in and answers it before I wake up and have a chance to even look at it. So thank you all for being part of this community. We're all learning together, and I think that's really awesome. Shoot. Okay, so the problem is that this is unknown. So that's great. So what okay. I don't think I can do this. I need to move through this to grab the thing, but maybe I don't save it to disk. Maybe I just read all this stuff. Maybe I just read all this stuff and then we just continue on. I just don't do anything with it. And then that way, from what Asitsu was saying, we'll get the blob later in the file. Okay, that already has the context. I don't need to add it again. Okay, this context, I already had a context in, oh, have I added context for all these? Let's see. That's another question mark. That has a context on it. That is an expect on it. That is a okay. So I have a context on it. I just don't do anything with this, which is fine. Okay. I tend to teach the beginners more than ToggleBit, so the super nerds don't gather as much in my channel yet. Yeah, that is true. I a lot of the courses that I've created are more geared towards beginners. Although I would love to say that I also add in some like middle level stuff. I don't have any senior level things in Rust though. There's plenty of people to watch that have like higher, mid, senior level stuff that I don't think that I can add to it at this point in time. Like I don't think I have any I think I would just be in pure competition as opposed to like a differentiator. Yet. Someday. Okay, so if I do this, we're not doing anything with these things. So I'll just ignore you. Now, if we run you, we initialize the get directory, and then we panic at unreachable code on line 77. What? Object type unknown? Uh-oh. Object type unknown. Okay, so read type and size. So I get the object type, new, object type and size. So I'm matching on one of these. So obviously it wasn't 1 through 7. So let's debug here. Creating object type. Object type. Object type of 0. You're doing good. You're about to continue reading chapter 7 in a Rust book. It only took you around 11 months of watching me and talk a bit and everything on YouTube to get to where you can understand a Rust book. Awesome. That's great. Yeah, I remember you reaching out earlier, and I'm really happy you're able to like make this progress and like continue moving forward. I know it can be frustrating, especially when like we're trying to help out and it's like just answering in text like in Discord is really hard to like. There's so often like the contexts are wrong, and we end up giving advice that like may not make sense to you in that exact moment, or maybe it's just like slightly wrong metaphor or something else, and we can't see a reaction to it, so we don't know if it hit or landed or not. So I'm happy that things are working out. Why did I just okay? We got 0. There is no object type 0. Invalid object type. So if you're an invalid object type, that means I didn't move the cursor enough. That's the only thing I can think of, right? So hold on, let's before we do, let's see, self unknown. Here we can do ePrint line. This can be error object type must be 1 through 7 got object type, and then we'll return self unknown. Okay, so now when we run this, we should see there it is. Error object type must be 1 through 7, got 0. Um, huh. Did I enable togglebit.io in it knows that it's a URL. I'm kind of shocked that Nightbot enables that. Did I enable that a while ago? I must have, right? Links, options. Oh, no, I did not. Okay, well, you got lucky. I am going to. I wonder if it's because of the semicolon in there. That's probably what it is. So if I add in togglebit.io, I mean, I'm assuming that togglebit.io is actually like toggle bits, right? Yeah. That's cool. Togglebit.io is now whitelisted. So you should actually be able to post real links to togglebit.io, and that won't catch you. Okay. Why am I getting 0? Okay, so I'm getting 0 because in clone here, I'm clearly not moving this enough. But it kind of works. Yeah, the typo made him lucky. Yeah, it certainly did. Okay. Now, so I'm reading through this. Okay, so let's go over what we're doing here. So we're gonna get the hash out. And so curse pack file, we read the hash. We get the context. Okay, so we get the context. We encode that, and then I get the commit, which is another request out. And then everything I do after that is something else. Now I'm reading the blob from the pack file cursor. Okay. So if I just do this, where read that, so let's not do these things. I wonder if there's something else that I'm missing here. Like I need more than 20 bytes. I need 20. It should be 20 bytes. That should be fine. Why aren't you fine? So we got the hash. Okay, what happens after the hash? Like if we're looking at one of these normal objects. Okay, we figure out where we are in the position. We get an object. We create a new vector that's going to hold our decompressed object. We create a decoder. We read to end the decompressed object. We figure out, okay, how many we put in. And then we seek to that position plus, so, okay, where we were plus how many we just read in. And then I save that to disk. Am I just off by like 1 byte? I'm worried I'm like off by 1 byte. Oh, my jump's gone? Wait. Huh. I thought I saved my jump. I must have restarted something? Oh, here it is. Let's trying to use my cursor to do stuff is not a good idea. Okay, saved you, so now I can go back to this async function handle ref delta. Okay, what if I want to not read 20, but 21 bytes? Corrupt deflate stream. Error running clone command handling normal object type as a commit. Oh. The apply delta does more reading. The apply delta? You mean there's more stuff than just the hash in here. Also, welcome back, Asitsu. Okay, so now we come back to here. I need to find the hash delta. Oh. After the offset or hash of the base offset, both deltafied representations contain a zlib compressed stream. Literally the next thing, and I think we even like watched this, read through this initially. This sounds familiar. The stream starts the size of the base object, redundant, and the size of the new object. The rest of the compressed stream is a sequence of instructions for building the new object. There are 2 types of instructions. Oh, okay, so wait a second. So this is saying that it gives me the hash of a blob, tells me it's a delta, and then that I could go outside of it, but then just gives me the delta here, which is like in its entirety. Okay. But it's a blob. Why couldn't it just say it's a blob type? I don't know. I'm asking that because I don't know enough about like the whys of like how this works to really know why a delta and not just the full thing. Okay, so now we have the data bytes and then the offset and size. Okay, so this is going to be more interesting than I thought. So I get the hash out. So we read the hash from the cursed pack file. And yay, we have you. After we have you, we get a zlib compressed stream the stream starts the size of the base object and the size of the new object. The rest of the compressed stream is a sequence of instructions for building the new object. There are two types of instructions. Data bytes, so append this... okay, wait. So then after... the rest of the... okay, so I need two sizes. So the next thing is getting two sizes which are in one... okay. But hold on. Is the variable length... okay, so I need to figure out where the size is for this one, because this is read offset encoding, which is not the same thing. So my guess is the size is going to be what we have in here. No, wait. I don't think I have size in here, do I? Oh, we have the read type in size. Oh, that's in process pack file. Oh. So in read type in size... okay, so I need this. So keep bits. Value. Okay, so the problem is it's not going to be type in size anymore. I just need the size. I just need read size, which kind of sucks. So what if I just do pub function read size? We'll have a pack file reader. And I just want a size, which should be a U size. Now, for the size, I need keep bytes value, so I need this resize encoding. So well, the size is keep bits, value, and then type byte size bits. So I want to keep bits. Okay. Value equals. Okay, so I want to read size encoding. Pass the pack file reader. Context. Name size coding. And then we're going to get the size. So this one I'm just going to return. I'll just do this way. Now we're going to keep bits, pass it in the value and the type byte size bits. return okay size. So that should be okay. So I just separated it from here. Now, if I wanted to remove these, we have the value. Oh, but the value is used in these two places for object type and size. That kind of sucks. So if I just want to resize only, we're just gonna use this one. This will be fine. It's fine. Everything's gonna be fine. So I want to handle ref delta. Okay, so I get the hash. Okay, so we read the hash in, and the next one is I need to get the size of the base object. So base object size read size, and then pass in the cursed pack file. Let's debug one at a time, right? And just do this over, like, just over and over again. So this is me handling ref delta, or I just call this base object size. Okay, so we get you, repo URI. I don't need that right now. So I should get something that looks appropriate, right? Base object size 8. Cool. I don't know if that's right or wrong. It doesn't look right. It looks really small, but it didn't crash. Search the size of the base object and the size of the new object. Okay, so size the new object. So now I get the new object size. Okay, now I get the new object size in here. Okay, let's try this. New object size is 12. The data is compressed. You want to call that with the zlib decoder. Wait, the size is compressed too? Wait, so wouldn't it tell me, okay, so starts with the size of the base object, redundant, and the size of the new object. The rest of the compressed, both delta representations contain a zlib compressed stream. The stream, oh, it is compressed. Okay. So I have to now decompress it. It starts with a base object. Oh, no. Okay, so I guess it's not, oh, no. We're going to have like an unknown amount of space. Huh. Okay. Now, I don't get the type and size properly, do I? I get the hash of what this is. I read that in. I can't do these. We're going to have to... Okay, you're also using read size encoding as that returns the size. Yeah, read size encoding returns the size, but I need to decompress first and then read the size. How did we do this before? We did this somewhere else. Was it down here? Yes, this is what we did. Okay, so we figure out what our current position is. We create a new vector. Oh, with the capacity of what the size is going to be. Ooh, do I get the size? Do I get the delta size? If I do, that would be great. So if I get that, let's try this. Let's debug ref hash delta size. Throw in the size there. Yeah, it says that size was redundant, which means that maybe this is the size that we have now for it. Ref hash delta size 8. Wait. Oh, wait, 12. Then 8. We got, okay, this ran twice. Okay, cool. So the first one is 12. So now I'm not using this URI anymore or the path. So let's pass in the size. I think they're U sizes, right? Type expected U size found U size. Okay, hold on. We can fix that. Okay, unused variable, so we're good to go there. Okay, so now we want to do the exact same thing that we did before. We want to create... I wonder if I want to move this into its own function then. To like decompress object. That kind of makes sense. But until then, let's just do this. I'm going to take our current position, decompressed object. We create a new decoder. We read to the end. We figure out how many got put in there. And then we seek this. We then change our cursor and we seek to the new place. And then... Okay, so I'm just going to do with those to begin with. Okay, so we have our current position. Okay, so with compress, we need our size. Okay, so we have our size. Decoder, cursed pack file. Why are you upset? Why can't I have this immutable reference to it? Why are you upset about this? Oh, cannot borrow you as mutable. Huh. Fine. Makes you happy. Decoder. Read to end. Decompressed object. Let count total in. And then seek this through. Okay, seek through. For reference, your first size was 1,311. Okay. So if I... Now, I haven't done anything with the decompressed object, but I'm assuming we're going to save it. Now, if I want to debug first, so our count is going to be count here. Let's see if that's 1311. We got 20. Also, you didn't crash. Why didn't you crash? Now I'm confused. Okay, so... Oh, right. Now call read size encoding and pass in the decoder, which is 20 bytes? No, it's not decoder. Oh yeah, this... No, wait. It's the decompressed object, right? I pass that in. So... Yeah. Don't read to end. Just call it a decoder? Now I'm... Wait. Now I'm confusing myself. In read size encoding, you take in a cursor. Oh, it implements read. And the decoder implements read. So before I read to end, I want to get the size. Is that what it is? So if I do let, what was this? This is the redundant size. This is the old base object size. And this is read size encoding. We pass it the readers. This would be decoder. Okay, let's say I don't do this read to end then right now. Which means I can't do the seek yet. But we'll get the... Let's just do a panic to end, because I don't want it to like continue on. What are you upset about? Decompressed object type. Oh, type annotations needed. Your bytes, right? So you're going to be a vec of u8. So if I run you, base object size 1311. Okay, that's what you got. Okay, all right. So then we do it again. So this is new object size. Then we do read size encoding. Pass it in the decoder. Okay, then we get the new object size. Is also 1311, which is, you know, the, okay, redundant. The vec capacity needs to be the new object size here. Okay. Okay, so now I have new object size. So, now decompressed object, I'm not using it, right? Unused. Okay, so now we're going to create you. You should figure out what you are. So we're going to remove you, and then you're going to be the new object size. Okay. Now I want to read to end. So because now it's the thing, right? The rest of the compressed tree and sequence of instructions for building the new object. Data bytes, append the specified bytes to the new object. The next bit is complicated. Everything's been complicated so far, which is, I mean, it's good. We're learning a lot. It is funny though when we say the next part is complicated in the middle of something that's complicated, because that just, all that really means is we're ramping up the complication like every time. The instructions are distinguished by the upper bit of their first byte. A data instruction starts with a 0 bit, while a copy instruction starts with a 1. In a data instruction, the remaining 7 bit. Okay, so I need to. I need to get the first byte of this and figure it out. If you thought this bit was complicated, just you wait. Exactly. And especially the bit part is great, because that's exactly what it is. Reads a single delta instruction from a stream and appends the relevant bytes to result. Returns whether the delta stream still had an instruction. Okay, so read bytes. So we get the thing with the stream. Okay, instruction. Get the instruction. If the instruction is true, complicated is our middle name. At least it's only complicated, right? If it was also complex, that would be more issues, more fun for us to work with. If instruction and copy construction flag is 0. If this code was a Facebook relationship status, the ad type stuff, even if I made the ads go away, I don't think this would make this wider, right? That'd be really awesome. Okay, what are you? Nope, that didn't make you any wider. Do you still have stuff over here? No. Oh, okay. Oh, cool. Fixed it. All right, that changed the site. That changed where I was in here, which is fun. Oh, right. Here's the, okay, so here's the apply delta instruction. Boy, okay. So my understanding of this is that the first thing we do is we figure out what the instruction is. So the instructions are distinguished by the upper bit of their first byte. A data instruction starts with a 0, while a copy instruction starts with a 1. In a data instruction, the remaining 7 bits indicate the number of data bytes that follow. A copy instruction is followed by an offset up to 4 bytes and a size up to 3 bytes to copy in the base object. The lower 7 bits in the instruction byte indicate which of these offset and size bytes are present. For example, consider this copy instruction. So it's an array, and we have the copy instruction. And so, okay, so it starts with that one. So the copy instruction, only byte 0 of size, only byte 0 of size is provided. Only bytes 0 and 2, okay, so like 0, 1, 2. So only byte 0 of size is provided. Only bytes 0 and 2 of offset are provided. And then we have offset, offset, size. Okay, so it's size and then offset. So this is saying we get only byte 0 and 2 of offset are provided. So 0 and 2, right? So 0. Oh, okay. Offset 0 and offset 2. So it skips offset 1 because it's just 1, 0, 1 instead of 1, 1, 1. And then the size, and then okay, in case we had multiple bytes of size, because it could be really, really big and therefore need multiple bytes. So much fun. Okay, so we're going to do read partial. So reads an integer of up to bytes. Present bytes indicates which bytes are provided. The others are 0. Read partial int. So this takes in something that implements read, which is going to be our stream, which is going to be our decoder. Oh, ad block starts in 5 minutes. Perfect. I'll probably take another break during that time because I skipped the last one. And then Zilby left us. I don't know if he wants to come back down here or not. He didn't hang out very long last time. Okay, so we start with value 0. For byte index in 0 through bytes, with bytes being a U8 that we pass in. Okay, so hold on. It's read delta instruction. So this reads read partial int. Right? Right down here. Okay. Oh, the copy instruction. Okay. Reads a single delta instruction from a stream and appends the relevant bytes to result. Returns whether the delta stream still had instructions. So we're going to return we're going to have a result here, which is just a vector. Okay, so a vector of bytes. So it's going to be the data. Okay, so this is going to be the actual blob in here. Okay. This is what I want to write in. I'm going to move this over to the left. And we are going to throw this in. I'm thinking I'm going to put this into process pack file because everything in here is implemented from this. So continuing on with this stuff. So we're going to have a pub function, apply delta instruction. So we're going to take in something that implements read. Okay, so we're going to have our stream, which is a mute reader. We're going to have a base, which is an array slice of bytes. And then we have our result, which is a mutable reference. Now, interesting. So this is a mutable reference to a vector itself, which is, I guess that makes sense. So I can use the vector stuff on it of bytes. And we're going to return a result with a Boolean in it. Okay. So our first thing we do, check if the stream has ended, meaning a new object is done. So instruction, I match on read bytes. Oh, I don't have read bytes. Uh-oh. Okay, so now I need to go up until I find where they had read bytes. There it is. Okay, read bytes. The first thing we do is check if the stream has ended. I thought we were talking about a different stream for a moment there. Yeah. It's context, right? Oh, and then this includes a const and usize. Stream mute r. We're going to return a result with a, oh, that's why I do that. It's a, okay. So we do that. Let mute our bytes. They're going to be equal to, so we're going to initialize them to an that. We want to stream read exact. And then we have our, the number of bytes. Okay, so read exact into the bytes. And then we're going to turn okay, and the bytes. Yes. Okay, so read bytes. We're going to pass it into stream. And I need to pass it in. This is called apply delta instruction. Okay, so read bytes. How big was this? How does it? Okay. I don't remember how it knows that. Oh, ad break just started. Okay. I'm going to leave this here in a broken state because broken states make it easy to figure out where you're going to continue on. All right. We're going to take a quick 5-minute break, 3-minute break, something like that, between 3 and 5 minutes. And I will be back to continue working on this. So I'll see you in a couple minutes.